All right, hello Algebra 2 people. Today is our second day of 1.7 notes. The previous video was solving absolute value equations, and today we're going to tackle inequalities. And as you've realized, inequalities often involve graphing the answer. Oftentimes that makes more sense, and you can get a real feel for what the solutions are when you have the answers graphed on a number line, which is nice. So we'll mix things up a little bit here. We'll do an example, maybe two examples, and then we'll write down a couple sentences to kind of summarize the details. So 1.7, solve absolute value inequalities, and let's just jump right in. For our first example here, the instructions are to solve, and then it says to graph the solution. And our first example is absolute value of 3 minus x, close the absolute value, is less than or equal to 2. Again, I want to mention that absolute value acts as a grouping symbol, but if you have a variable inside, or you have a sum or a difference, we have a difference in this case, you don't want to try to evaluate the absolute value on the inside here. You don't want to make this 3 plus x. That is a misunderstanding. You don't want to do that. Instead, what you want to think about is that what's on the inside could be two possible answers. So it could be a positive 2 and it could be a negative 2, and we're still going to set this up that same way. Once the absolute value bracket is isolated, you can go ahead and write your 2, in this case, inequalities. You're going to write 3 minus x is less than or equal to 2. That's a possibility. Also, though, your 3 minus x could be a negative 2. Now, here's what's interesting. You know how before, when we talked about if you divide both sides by a negative, you flip the sign, or if you multiply by both sides by a negative? This situation counts like that. So what's interesting is when we change this 2 to a negative 2, the symbol is going to flip. So for this part right here, we're going to go greater than or equal to negative 2. And it's all because of introducing that negative. From there, you solve them kind of like normal. Now be careful here, you're not going to add 3. You're going to undo this 3 by subtracting a 3. Leaving behind a negative x is less than a negative 1. And then right here, you'll divide by a negative, and because you're going to be dividing both sides by a negative, the sign here will flip. So there's a lot of flipping going on, isn't there? Let's go to the other side. Subtract a 3, subtract a 3, negative x is greater than or equal to a negative 5. Divide by a negative, and again, the sign is going to flip. Okay, so what we have here is a compound inequality. We've got two separate inequalities, and they're both solutions.
Melissa James, please call the main office at extension 3000.
We're going to figure out if this is an and or an or problem based off of the graph. So it may turn out that we just write or in between and box it in and we're good. But we may have to rewrite this as an and inequality, which is where you've got the x in the middle and then numbers on the outside. But we're not going to tell until we graph it. So let's graph it. Always put the smaller number on the left, bigger number on the right. These both have equal signs, so they're going to be dots. And then we want to shade accordingly. This says x is greater than or equal to 1, so that's going to be going that way. This says x is less than or equal to 5, that's going that way. So it turns out we shade in the middle. And when we shade in the middle, that means this was an and inequality. It was an and inequality, so we're not done. We got to go one more step. We got to rewrite this as an and inequality. It's not as hard as it sounds, because here's the thing. Whenever you write an and inequality, the lower number's on the left, the bigger number's on the right, the x is in the middle, and here's the thing to remember. As long as you write smaller number on the left, bigger number on the right, like you have to, as long as you do that, it's always going to be less than, less than. But in this case, it's going to be less than or equal to, less than or equal to. Now, if you're thinking that's a little too easy and maybe I messed something up, double check it. This says the exact same thing as these two. X is less than or equal to 5. X is greater than or equal to 1. It says the exact same thing. And there you have it. Okay, a lot of sign flipping, a lot of paying attention to detail when you have those negatives, when you introduce a negative, flipping the sign. Pay attention to those details. All right, let's do another one, and then we'll kind of summarize the steps that we need to be aware of. For our next example, let's do absolute value 2x minus 3 is greater than 5. Because the absolute value bracket is alone by itself, we're ready to write two inequalities. One's going to consist of 2x minus 3 is greater than 5. Well, that's a weird 5. Okay. The other is going to consist of 2x minus 3 is less than what? Negative 5. We introduce a negative, we flip the sign. I kind of had my pause there a little funny. But it's negative 5, and we got to flip the sign. We introduce that negative, flip the sign. And we solve it. This side I'll get 2x, we'll add a 3 over is greater than 8. Divide by 2, x is greater than 4. This side I'll add the 3 over, I'll get a negative 2. Divide by 2, I get a negative 1. I don't know if it's an and inequality or an or inequality until I graph. So draw my number line out. Negative 1 is smaller, 4 is bigger. They're going to be circles. And now let's find out which way we're going to shade. We're going to shade x is greater than 4, x is less than negative 1. So we're shading on the outside. We're shading on the outside. So this is an or inequality, compound inequality, and we are done. Just like that. Here's the thing, I'll let you in on a secret. I actually prefer it if you graph it and then decide if it's an and or an or problem. But I'll go ahead and share something with you. It turns out that when you have an absolute value inequality, if it starts out with a less than sign, less than or equal to, it's always going to be an and problem. If you have a absolute value inequality and it's greater than, guess what? It's always going to be an or, okay? I would prefer that you decide once you've graphed, okay? I want you to be accurate to that point, but it is kind of a good way to check. If you're graphing it and your graph's all weird, they're shading both to the right, something's wrong, and you're going to realize it because it needs to be an or inequality, and you'll know to go back and fix some things. Okay, so hopefully you got all this down. Let's kind of summarize a little bit what we did here. So what you're going to do is you're going to write two inequalities. But you're going to make sure to flip the symbol for the inequality with the negative. And you can look back at the examples we just did. Write two inequalities. Make sure to flip the symbol for the inequality with the negative. After graphing the solution, you may find, oh, I'm sorry, let me say that a different way. After graphing the solution, decide if it's an and, or an or inequality. And if it's an and inequality, you've got a little more work to do. You need to write it as a compound, as a compound inequality. You got to squish it together. Or stay separate. Okay? All right, so those are the steps there. Let's see, let's do, oh yeah, and I guess if you want to write down, you can write down that little trick I told you. It turns out that less than absolute value ones are always and greater than absolute value ones are always or problems. That is, I got to stress, it's only with the absolute value brackets alone. If there's that stuff outside of the absolute value bracket, you got to move that stuff over first, then decide if it's an and or an or problem. But that's really not necessary. You don't have to stress about that too much. Let's do one more problem. I think I've got room down here.
Can you send the summary to the counseling office?
Let's do one more. Absolute value 2/5 n minus 8, close the absolute value, plus 4 is greater, wait a second, what do I want to do? Okay, we'll go less than. Is less than or equal to 12. Okay, so oh, hey, this is just what I was talking about. Do you see how it's not the absolute value bracket by itself? When you're working absolute value problems, you don't write your two equations or your two inequalities until the absolute value bracket is all by itself. So to do that, we are going to start out by subtracting the 4 over, in which case we now have 2/5 n minus 8 is less than or equal to 8. From there, you're going to write two inequalities. One will be 2/5 n minus 8 is less than or equal to 8. The other is going to be 2/5 n minus 8 is greater than or equal to, you flip the sign because you introduce a negative like so. Notice again, class, leave the interior alone. Leave it alone. Change what it's equal to or what it's the inequality on the other side. From here, let's solve it. Add the 8 over, we'll get 16. Remember, don't divide by a fraction. We don't want to do that. We're going to instead multiply by the reciprocal. Don't grab your calculator just yet. Remember, this is 16 over 1. The 2 can simplify with the 16 to get 8. 8 times 5 is 40. On the other side, add the 8 over. We get 2/5 n is greater than or equal to 0. Multiplied by the reciprocal to undo it. We get a whole lot of 0. Make our graph, and then we'll decide what type it is, and we'll rewrite it if we need to. So we've got 0 on the left, 40 on the right. They're going to be dots. And it says less than or equal to 40, greater than or equal to 0. We shade in the middle, which means this is an and problem, isn't it? It's an and compound inequality, and we need to rewrite it. Remember, it's not so hard. Just remember, smaller number to the left, bigger number to the right, and in the middle, always less than, always less than. But in this case, we need a equal to as well. And then we've got our answer figured out. All right, that's all I've got for you. Hey, the practice for this is page 56, numbers 43 through 61, odds. These are odd, but then I also want you to do 62. You know, if these notes were pretty short and you got through them pretty quick and you're still feeling the math bug a little bit and you want to get started with this, that's great. I'm worried that some of you aren't finishing the practice in class. Also, just, fire drills or whatever, class gets shortened, it kind of messes things up. So if you want to be a little ambitious and on the ball, you can go ahead and start this assignment here. And that way you don't have as much to do in class. All right, hey, thanks so much for watching and have a great day.